Okay, welcome back. This is the second part of taking a look at the R.U.B.E Box2D editor video. And if you haven't seen the first part, you might want to go and look at that, because it sort of explains a little bit more about the editor itself and what the whole purpose of this video is. For everyone else, let's get started. In this video we're going to be spending a little bit more time in this folder here, Box2D testbed, and we'll be using the files that we created in the last video, these ones here, to load in the level, and then we'll have to write some C++ to do something with it. So what I'm going to do first is let's have a look at what we already have in this folder. And in this folder we have source folder. This is Box2D source. Data files. Oh, look at that. Very similar to what we just made. A folder full of images and a JSON file. So go back out of there. And binaries. Inside this one we have same thing actually. Images, JSON file. And then we also have some executable files that I've built for each platform. Linux, Mac and Windows. I'm using Linux here, so we should be able to run this one and load in the example here. This is a tank, obviously, and this was made with R.U.B.E, basically just like we did with the level before, except it's quite a bit more complex. Obviously we've got a whole bunch of joints and tricky stuff going on there. So what we're going to do is we're going to take the source code for this and we're going to add another test in the list here. So, source code. Actually, first, in this data files folder, we'll copy in our files that we just made. Level 1 JSON, and then the file folder with images. So back into data files folder, should paste that in there. Then we will go into the source. And in here we have Box2D, and so the testbed files are under here, and we'll look at those in a second. First I want to just build the project and get it running, just so that we can look at the tank example first before we steal the source code from it. So for that we will use Qt Creator, which is a program that I cannot praise enough, really. It is just great. I love it. And one nice thing about this program is that we can just drag and drop the CMake file straight onto there. And this will allow us to basically set up a project in Qt Creator without really doing a whole lot of work. I will do a little bit of work here, and I will say that I want to set things up as a debug build. Just in case something goes wrong, I might want to see where it went wrong. And another thing that we'll have to do here is switch from using the default Hello World project to the testbed project. Now, I'm just going to hit F5 here and compile and run this. And it should run, but it won't find the JSON file and the images file, because it's going to be building the executable in a different folder. And if we have a look, let's go back out to source, and if you build things in the default location, Qt Creator will make this folder here next to the Box2D folder. And we can see, did not manage to load the JSON file there. And if we have a look in the application output, we can see could not load JSON file. So the problem is the executable has been put inside this Qt Creator build folder, testbed. So it's there, and it's expecting to find the JSON file here in this current working directory. So what we really want to do is make this file, we want to copy this after the build has finished. We want to copy this into the data files folder. So to do that, we can add a build step here in projects, build step, custom, and we want to copy, and we want to copy what? This file, right? We want to copy this file, and we want to put it in this folder. So I think we can just drag and drop these in here. This folder. And we have to get rid of these file headings. And I also found that because we have brackets in here, we have to enclose these file names in quotes. Like that. And we also have to enable this build step. So let's look at our compile output now, and we'll go back into our data files folder, and this time when we compile, we should see testbed pops up in this folder instead of the other one. Well, it's been copied through, so this is where we want it now. And now if we run it from here, we should find that it loads up the tank this time. Okay, much better. Now rather than coming here and double clicking on this every time, I'm going to set up Qt Creator to use that folder as the current working directory. Data files. So this is the executable we want to use. Now I should just be able to hit F5 and okay, everything's happy. Good. Now, what's next? We are going to come to the source, Box2D, testbed, tests, and we want to find this one here, load R.U.B.E. This is the example R.U.B.E loader that comes with the R.U.B.E download when you download it. So this is the one that's loading the tank in. So we're going to copy that, and we're going to call it, say, level1.h or load level. And right, we want to edit that, and we want to change everywhere that says load R.U.B.E, and we want to call it load level. Okay, save that. And we also need to come in here, and in tests we need to go into test entries, and we need to add load level, and we need to add another entry here, load level, and it's going to be load level. So that should give us an extra entry in the list there, and I'm just going to take a bunch of these away because the list gets incredibly long. That. Right, let's run that. What do we get? Okay, tank is loading in. Oops, load level. Load R.U.B.E. What do we get there? Tank again. So we just need to change the JSON file that's being used to load, and that is here, JSON, what do we call it? Level 1, right? Okay, run that. Right, this time we have the level that we created just before, except running in the Box2D testbed. So now we can do a little bit of C++ to make it do something different. So the first thing we need to do is load in all the objects that we named in the R.U.B.E file, and to do that we'll need to have somewhere to store them. So right here at the bottom of the class I'm going to add some class variables to hold some bodies, a fixture, and B2 vectors. This is for the star home positions. Remember, we didn't really want to keep those bodies. We just want to load them in, get the position, and then delete them. So all we need is a B2 vector for those. Right, now in the constructor, what do we have here in the constructor? Let's have a little look at that. We make a B2D JSON object. This is the JSON loading class, and we try and read from this file, and if it worked, then we need to do a few things. You won't have to do this in your program, obviously. This is just because we're trying to fit this into the test bed. We delete the test bed's world, and then because we've pulled that world out from under the test bed's nose, we have to do a little bit of work to replace it so it doesn't crash, basically. So we need to replace the world, and then after that we need to reset a few things like contact listener, debug draw, and finally we need to replace the variable ground body that it was using to create mouse joints. When you click on something in the test bed, it creates a mouse joint between this ground body and the thing that you clicked on, and if this is not there, you get a problem. This next bit here, I'm just going to gloss over that for this video because it's not really recommended practice. This is makes use of a class called B2JSON image, which you can use to get the corners of the images that we defined in the editor, and it'll allow you to draw them. And it's not really the subject of this, and it's quite specific. See, this one's for OpenGL. Depending on what you're doing, you might be using iOS or DirectX or something else. So suffice to say that we load in the images in however format you need to load them in, and we're sorting them as well, back to front. And likewise, in the step function here, we have another bit that I'll gloss over in the same fashion to draw the images. So you can look into that a little bit more if you download the source code and you need to check it yourself. Right, so back to this. After all this stuff is done here, we need to access from the JSON file. We need to do this, get body by name, and we want to set the blob body to the body called blob, the wall body to the body called wall, etc. Then we have 3 star bodies, and this is a little bit different. We have a fixture for the goal instead of a body, so we load that as by calling get fixture by name. And then finally we have something. We have to do something a little bit different for those home positions at the top left, because we want to delete the body and just keep the position. So we start off doing the same thing here. We do get body by name, and we only put it into a temporary body. We take the position there, and then we remove the body, and we need to do that 3 times, obviously, like that. So this remove body function we haven't defined yet, and we could perhaps in your game you might be able to just call world delete destroy body, might be okay, but for what I'm doing here I also want to take care of those images that we're drawing to stop them from being drawn if their body gets removed. So I have this function here, remove body, and as far as Box2D is concerned, all it does is destroy the body, like I just said, world destroy body. And there's a little bit here that I'm going to gloss over again to do with the images. It just removes the image from the array if they had a body and that body was this body that was being removed. Okay, now what can we do at this point? We can, I guess we can run this and just check that nothing crashes. That would be the start. Okay, and we can see here in the top left those 3 stars that were there that kept falling down are gone. So we obviously found them okay. Blobby is in there, everybody's happy. Okay. Now, one thing that's pretty easy to do is get rid of that wall. So we'll add a function here, keyboard, and when the user hits the A key, if the wall body is still there, we'll remove it. So that's using the remove body function that we had above there. And then we'll set it to null so that we don't do that again. So if the user hits A twice, nothing strange is going to happen. And we'll give that a quick run. Okay, A. Right. So that's working okay. Now we need to check when we hit the stars. So once again we'll need to add some class variables to store the status. These are just going to be booleans, and one boolean just to keep track of whether we have hit the goal at the bottom or not, and then 3 booleans, one for each star. And of course we'll need to set these to something in the constructor so that we don't start off with them being garbage data. So we just set each of those things to false at the beginning of the level, at the beginning of the when the level is loaded. And to keep track of what status they are, just as an extra confirmation, in the step function I'll use the drawString function that the Box2D testbed has, just to draw a line of text on the screen at the top to say whether we have got stars 1, 2 or 3, or whether we've hit the goal. So we can just check the status of these variables here at any time. And the status of those variables is not going to change unless we have some kind of a contact listener implemented to do something when the star and the blob touch. So let's do that. We have begin contact. Begin contact is all we need. We don't need to worry about end contact or anything. So we start off begin contact, we just get the fixture from the contact and then the body from the fixture. And the only collisions we're interested in are where the blob hits the star. So we can do something like this. If body A is the blob body, then we have a function here, handle blob hit with fixture B. Or if body B was the blob body, then we handle a blob hit with fixture A. So when we enter this function here, handle blob hit, we know the blobs hit something and we know that it's this fixture. So we can write a function that's a little bit more specific, and it's a little less verbose, I think. So let's write that. Handle blob hit. First thing we need to do is check if the fixture that was hit is the goal fixture. If it was, then hit goal is true. And then we also need to check for the stars. This case we need to check the body, right? Because when we created the level in the editor, we named the bodies and we loaded the bodies in here, see star bodies. So we need to get the body there, and let's call it other body. So if the other body was a star, then we have this function here, handle star get. So functions getting more and more, aren't they? So we have a function here. So this just lets us know that we've hit that star and we should do something about it. So handle star get. Sorry about that. I seem to be banging my microphone. Right. So handle star get is this function, and all we do in here is check that we haven't handled this star already. If we have, we return. Otherwise, we just set that boolean to true. And then for starters, we'd like to set the type of that body to be a dynamic body. So at the moment, this is just going to make the star fall off the bottom of the screen when the blob hits it, but we can give that a run now and see how it turns out. And it's not going to turn out very well, as we'll see in a second. Let's watch. So what happens here? Okay, go. Oh shit. So we managed to crash the program, and if we have a look here at the position that the program stopped at, not really a crash, is it? We can see that we're inside Box2D's code here. We're trying to set the type, but the problem is that the world is locked because we're in the middle of a time step, and it's easy to forget that. And this is probably one of the most common problems that come up when people are just starting out with Box2D and they're trying to add things or remove things inside a time step. So this I obviously knew that was going to happen, but I left it in here as a good example of how, see in this case we have this function calling from this function, and then this function we came into from here, and it's easy to forget that we're actually inside the world step all the way through here. So it's a little bit awkward, but what we need to do here is, instead of immediately handling star get right away, we need to make a note of which one of these, this number I, which one of the stars it was that got hit, and then after the time step we can remove it from the world. So to do that, we'll need a class variable to store that information, and it can be an integer, and we're just going to store the index 0, 1 or 2 to tell us which star we hit. Ideally it would be a list or a vector or something like that, but in this case we know that we can only hit one star at a time because the stars are spaced far apart, so an integer is good enough. So first things first, let's set that to -1, so this is to signify that we have not hit any stars at this point. And then in the begin where are we? Handle blob hit. In handle blob hit, instead of saying handle star get immediately, we're going to say process star index equals I. So whichever star it was, we just make a note of that. And then after the time step, where are we? Where's time step? Oh, up here. And then after the time step, we can check if the index is not -1, then we must have hit something. And here, now we can finally call handle star get, and then we'll set this back to -1. So it's a little bit of a nuisance, but it's better than crashing, isn't it? So let's try that. Oh, I think we're still debugging. Yes, abort debugging. Right. Okay. Alright, so now the stars just fall off the bottom of the screen, and we can see over here the Boolean statuses that we had are changing when the stars get hit, 1, 2, 3, and then also when we hit the goal, that's changing as well. Okay, so everything's working so far so good. We don't really want those stars to fall off the bottom of the screen though. We want them to zip up to the top left position there. So we'll make a mouse joint to do that. that also in handle star get. Right after we have set the star body to dynamic. And at this point I finally remembered the thing that we forgot in the first video, and that was to set each of these star bodies to fixed rotation. And you could go back to the editor and change that, which is probably the best long-term solution. I'm just going to set the star bodies to fixed rotation true at the same time as I make them dynamic. It'll accomplish the same goal. So let's give that a quick check. The mouse joint that we're creating is pretty typical. It's a little bit weak, at least it's weaker than the typical mouse joint, but it should be enough to move those bodies. So let's give it a try. And what do we have now? Still not exactly what we want, is it? But we can see if we try and pull this star here, we have made a mouse joint. And if we reload, obviously it wasn't like that to begin with. It only gets that way after it's been hit. So it's just a matter of setting the target to the right place. At the moment the target has not been changed from the 0, 0 position. Mouse joints are a bit weird, but what we need to do is set the target to basically this point minus this point. In other words, the vector from A to B. So let's do that. I have that over here. Let's copy it in. No, that's not quite what I want, is it? This one. So we want to set the target of the mouse joint to the home position minus the current position. So run that, and let's see if we get anything better. Go. Okay, that's looking quite a bit better. Mouse joint is working, it's pulling things to the right place, and the hit goal is detecting yes. So really that's about all we needed to do here. Of course, to finish this properly and make a proper game out of it, you'd need to do something about this here. You'd need to destroy this body and maybe play some nice animation. If you've actually played this game, the original Flash game, you see the pipes sort of swelling as the drop goes up and then the tree grows and so on. But that's about as far as this video is going to go. So hopefully this wasn't too long and boring. Obviously if you're listening to this part, you either fast forwarded it a lot or you listened to the whole thing. Anyway, so this program, like I said, is not quite ready for release, but it's not far away. So if you're interested in making games and levels like this, you can look forward to some proper documentation and a whole lot more of these long-winded video tutorials. Proper tutorials, mind you, not just quick whisking through everything. Anyway, that's a story for another day, so I'll see you then. Bye.